I'm Anil Kumar and we will discuss application of composition of functions in this particular video. We'll see how we can relate one variable with the other uh, by applying composition of functions. As you know, area of a circle can be written as pi r square. When I say area is pi r square, it means area is a function of r, the radius, correct? So we have a function which is area, and that is related with the radius of a circle, right? So we could write this as a of r equals to pi r square. Now we also know that we could write circumference of a circle in terms of r, so we could write a function circumference which is 2 pi r. So that relates circumference with the radius. Now we kind of have a relation where area is related with radius, circumference is related with radius. Now how can you relate circumference and area? That means we want a relation so that if I know the circumference of something, I can get the area. Now this really means if I know radius of a circle, I know the area. Now the question is, if I know circumference, then what is the area? For example, if I say if circumference C is equals to 10 meters, right? In that case, what is the area which we will get out of 10 meters of circumference of a circle, right? So that is the equation, right? So if you have a circle, then you know that the area of the circle is related with the radius. So let's say this is the radius. Now the idea is, if you know the whole length around the circle, then what is the area? How do we relate that? And that we could do with the help of composition of functions. Now what we can do here is, as we know area in terms of r, let us see what is radius in terms of circumference. So what we will do now is we'll write radius in terms of circumference. So we can rearrange this particular equation and say r is equals to circumference c divided by 2 pi. So in a way, we have radius in terms of circumference, right? Which is c over 2 pi. Now we know area in terms of radius r. Now this r can be substituted there. That means we are talking about composition of function, right? A function of a function. So we can write down a function which is area in terms of circumference, and we say area with r. Now we could write this r as a function of circumference. Do you see that? So r as a function of circumference. And then get our formula. So r as a function of circumference is c over 2 pi. So what we get here is area as independent variable, r of c becomes c over 2 pi. Do you get the answer? Now we know area function is defined as pi r square. So we could write this as equal to pi. We'll substitute c over 2 pi for r, right? So we'll get c over 2 pi whole square, right? Now this could be expanded and simplified. So we get pi times c square over 4 pi square. Now when you simplify this, you can write your expression as a composite function which is area in terms of circumference, right? So area in terms of circumference, as pi and pi cancels, we get c square over 4 pi, right? So we got a new function which is area as a function of circumference could be written as c square over 4 pi. Do you get the idea? Once we have this function, we can find what's the area when circumference is 10 meters, correct? So let's write down 10 meters here, and we say area for 10 meters of circumference is 10 square divided by 4 pi, correct? So let's use the calculator to find the answer. So we have 10 square, which is equals to 100, divided by, within brackets, 4 and pi, right? So that is equals to area of 7.957, let's say 7.96. The units for circumference is meters, so this unit will be meters square. So that is how you can find area directly from circumference. Do you get the point? So composition of functions help us to relate one type of variable to the other, right? And there is no limit to it. You can keep on relating these variables to one another and find so many relations, right? So from the area you can get to volume, right, of number of circles piled together, right? So if you have number of circles piled together, it will become a cylinder, and the volume will be this area, cross section area, times the height. So that is how we can now introduce more variables and connect them and generate formulas using composition of function, and that is a huge application. I hope you understand and appreciate it. Thank you and all the best.